you have the monster here. Then the second largest one's called the baby monster. Okay, and this can be found inside. This can be found inside the monster, as you might expect. I think that's got size around 10 to the 33. Okay, so quite a bit smaller. I mean, that's the second largest. The smallest one, so I said the first ones were discovered in the 1860s. I think the smallest has got about size 8,000, just a little bit under 8,000. But generally, they increase in order, and they're relatively large. Okay, so I mean, this is some sort of like, tongue-in-cheek pictorial representation of the sort of the classification of finite simple groups. So each column in the main block here corresponds to one of these infinite families that we talked about, which crop up. Okay, so like for example, in the very far right-hand side here, we've got all the groups which have prime size. So the size is the prime number. So we see C2 here, which was like our group S before. C3 is like the group R, and then we have one for each prime number. And then all the other ones here are the ones which we didn't really explain. So these are the simple groups which belong to natural infinite families, but which do not have prime size. Okay, but then of course, because of the existence of the sporadic groups, we have this collection down below here, which do not fit into any of the, which do not really belong to this main table. These are the sporadic groups, and they're arranged in order of size. So at the very end, at the very sort of extreme here, we have the Matthew group M11. So this is one of the ones which is the first one, which was discovered in the 1860s. That's got order 7,920, and then they go up, and in this direction here, we end up here with the monster. A lot of the symbols here are the symbols here denote essentially the person who discovered the group for the first time. So M for Matthew, J for Janko, HS for Higman, Sims, and so on.
Who discovered the monster? Not someone called Monster.
No, not someone called Monster, actually. No. So the baby monster and the monster are the only ones, I think, which don't have that property. So the monster, the existence of the monster was predicted many years before it actually was constructed. So I think the existence was conjectured in around 1973 by Fisher and Grice independently, and then it was constructed by Grice originally as the symmetry group of this object in this enormous dimensional space around about 1980.
Poor old Grice, has he been ripped off by not having his name attached to it?
Well, sometimes it's called the Fisher-Grice monster. In fact, Grice actually in his paper called it the friendly giant. That was his terminology for it, but the monster is Conway's terminology, I believe, and this is stuck.
What's the holy grail of monster group research? Like, what does someone have to find out or publish and say? Like, what's the silver bullet paper that you would love to read about the monster group? That's
a difficult question. I mean, I suppose one of the areas where a lot of research has looked at in recent years is connections between the monster and other areas of mathematics. So there's this idea of these moonshine phenomena, which connects the monster to very fundamental objects in number theory on the one hand and mathematical physics on the other. And this is really not fully understood. So I think people are sort of interested, on the one hand, in sort of from a group theory point of view, just in terms of the properties of this group, but also I think the exciting stuff is really these connections with the monster and these other parts of mathematics.